Hello there, children. Today, today we're going to continue to look at solids of revolution, and the only thing we're going to do different than yesterday is we're going to add in rotating these things around a vertical axis. So today we'll have y's and dy and integrating with respect to y. So this is what we looked at yesterday, and with any time we have a hole, we have to use our washer method, and again, it's the area of this whole piece minus the area of the white space, or the area of the indent. So yesterday you practiced that, or this weekend you practiced that, but we only did it with respect to x. So today, let's change it. Try this question. First, set up your graph. So I'll give you a moment to do that. And then I will show you my graph. So graph, pause the video, and then take a look. All right, so I bet your graph looks like that as well. And so our bounded region is in between x equals 0, y equals 4, and the line y equals square root of x. And so now we're talking about doing something around a vertical axis, right? This is the y-axis over here. So we need to write everything. We need to solve for x here. So to get the square root of x alone, just square both sides, right? So now we're going to be looking at the equation y, or x equals y squared, which is this guy. And when we're rotating around the y-axis, we're back to right minus left, right? Just like on the quiz, same exact way as we did with the disk method. So the nice thing is, speaking of the disk method, if you look at the rotation, if you rotate this, there's no white space, right? This is a disk. So not bad, we can just write our disk method. So we're going to have the square root, not the square root, sorry. We're going to integrate. Don't forget our pi on the outside from 0 to 4. And it's right minus left, right? Y squared minus 0, so we just have y squared. And don't forget to square it, because we're talking about volume dy. All right, so that's something we've already practiced. But now let's change it a little. Let's actually add in some white space so that we can use the washer method. So I'm going to change the example, but now we're going to revolve it around x equals 20. So you can change your sketch if you want, or you can just extend your line, and it should end up looking something like this. So now, instead of revolving around the y-axis, we're revolving around x equals 20. And it's extremely similar to the last homework, except now, again, it's just a vertical axis. So some people, I think, liked showing the entire piece and then subtracting the white. So if you really look, the entire piece, if you're including the white and the shaded area, is a box. So if I want to describe the entire area, again, like our formula says, it's the entire area minus the white space. Well, the entire area is going to look like this, right? You're going to have this huge block, right? And so to describe it, when we're doing right minus left, well, it's 20 minus 0. And let me make this box a little smaller so we could fit everything. So if we do, again, we're integrating. We need our pi because we're talking about volume, 0 to 4. So the entire piece is going to be 20 minus 0, quantity squared. And now, sorry about the bad writing, I'm trying to use the pad, not a mouse. And now let's subtract the white. Well, to describe the white, again, this is the box, and now the white piece, it looks like that, right? This side is 20, this is our square root, or in this case, y squared, and so let's describe that. So I have 20 minus y squared now. So the white space, the way to describe that area is 20 minus y squared. And again, square that quantity. And close our parentheses, dy. And then I could, again, type that in if I really want to know the area. But that's how we're doing these questions, just like we did area, just like we did yesterday. And so today, you'll continue to practice exactly this. Here is your classwork/homework. And again, before you worry about disk or washer, see if it's a disk, well, that's like the question we did over here, every part of your shaded area is touching your axis of rotation. And it's going to be a washer where you have this subtraction, well, if you have this white space when you're rotating it, right? You have the whole piece minus that, and so we need our washer. And also note, if you look back at 7.2 and you have a little extra time, really look through all the questions we've done. We've done the majority of the questions up to 24. Make sure you can efficiently, notice is it disk or washer, and what am I rotating around? I will see you tomorrow. Thanks.